All right, hey, good afternoon, everybody. Can you guys hear me? All right, so kind of weird with all the noise in here. Hi, my name is Barry Davis. I am a general manager in Intel's Barefoot Switch division. I am here today to talk to you about the Intel Intelligent Fabric, utilizing OCP standards and P4 programmability. And let me say that, this is my first event seeing real people in about 20 months. From a work perspective, not from a personal perspective. So I'm actually really, really excited to be here. Okay. All right. In June of this year, Intel rolled out its Intel vision for data center of the future. Okay. Now, this is a very comprehensive vision. It's ever evolving, still changing. But at its core, it's got CPU, general purpose CPU services, application-specific or workload-specific services, computational storage, all connected together with a programmable network fabric that brings all those resources together in a very efficient manner. Today, we're going to focus a little bit on that data center intelligent network fabric. Before we do that, let's talk a little bit about the challenges, because they do exist and they're also growing as well. First, the data challenge, and we hear about this one all the time. I think this is by 2025, IDC is saying that we will be producing 175 zettabytes of data per year. That's a phenomenal amount of data, and I don't know what we're going to do with all that data, but nevertheless, it is being produced. 5G, AI, VR and AR, streaming services. I mean, the workloads are phenomenal and they're real. But it's more than just that, right? There's additional set of challenges. The move to cloud native architectures, container-based processing, automation, orchestration, and the advent of microservices, moving software applications from monolithic to distributed, has a big impact on the network. AI has a huge impact on the network, not just in the amount of data being produced, but the types of data and the types and the latency required for that data. It's moving to a distributed scale-out world, right? Disaggregated everything, disaggregated storage, disaggregated memory, changing the way our systems are working. The operational challenges of figuring out what's going on with your network and keeping your network up and running smoothly is becoming a big, big challenge. And finally, and maybe almost most importantly, the increasing investment in CapEx and OpEx that operators are having to utilize in trying to prevent that from occurring. So networks need to not just have more bandwidth, but networks need to get smarter as well. All right, so where does that lead us? That leads us to our vision, which we brought out in that Data Center of the Future talk, which is the Intel Intelligent Fabric. So optimized for cloud, edge, and even potentially comms in HPC data centers, it's a set of end-to-end optimizations across CPUs, Ethernet IPUs and network adapters, Ethernet switches, and optical modules. And so what we're talking about here are hardware optimizations and, of course, software optimizations to bring intelligence, performance, and control and observability to the network operator and to the cloud operator. Now, Intel's got a long history of standards, and the Intel Intelligent Fabric is no different, right? All this is based on open source standards. For example, P4 programmability, SONiC, Network OS, an OCP project, eBPF, DPDK, the new IPDK, a new open source framework and API, framework of API and drivers for infrastructure acceleration and management that runs across CPUs, IPUs, switches, and DPUs as well. So we're going to bring all this together for ease of use, right, to allow workloads to be brought onto the network and off the network efficiently and easily, to address that massive bandwidth we talked about, right, to provide self-monitoring, self-analyze, and self-healing so networks can actually run efficiently, okay, provide that enhanced security, because security is always an issue, right, and then improve density, power, and cost to address that OpEx and those CapEx challenges which I spoke about earlier. By the way, if there's any questions, please feel free to drop in, or we can wait till the end. It's kind of up to you guys. Okay. So I talked about three benefits of the intelligent fabric: intelligence, performance, visibility, and control. Let's talk about a few of those examples. First off, on the intelligence side, fully customizable P4 programmable pipelines across multiple data plane targets, switches, CPUs, FPGAs. Intelligent packet processing for AI and ML workloads for acceleration purposes. Bringing FPGAs to switches for expanding table sizes and buffer sizes, making them more intelligent and smarter. Enhanced security, enhanced network security through Intel CPUs with SGX for secure enclaves and TDX for VM isolation. So lots of examples, and these are just a few today, more coming tomorrow. On the performance side, we're talking about at least 25 terabit per second switches, bisectional throughput for networks. We're talking about 112 gig SerDes, right? The latest and greatest in terms of physical interfaces. High-speed silicon photonics for both short and long reach across the data center. And finally, power optimizations, because performance can never be alone, it's always performance against power, obviously. Finally, the third vector here was visibility and control. And there's a lot to talk about here, and I'm not going to spend too much time, but the first thing I'm going to talk about is enhanced congestion control. And if you go to the virtual booth, I know that Intel is talking about its remote PFC work, which is priority flow control, which is one of the technologies we're producing to help with enhanced congestion control for modern networks. So go check that out. Some of the other things we're talking about is INT integration across the platform. Today we've got in our switches. We're bringing it to different more sources of INT into the platform. And as a matter of fact, one of the things that Intel has done is we've recently taken our host INT implementation and open sourced that to the Linux community. Some of the other advancements and vectors here, part of the vectors here, our Deep Insight software for per packet flow analysis. So lots of ability to actually bring that telemetry into the platform and allow you to control the next generation of control. So one of the other things, so I talked about, for the Intel Intelligent Fabric, I talked about software optimizations. One of the ways that we do that is to an end-to-end software architecture and a consistent programming model across servers, IPUs, FPGAs, and switches. And you can kind of see that up here. You see a P4 front end, P4 program across multiple data plane targets. For example, you see a switch using P4 DPDK. You see the new Mount Evans IPU. You see an FPGA-based IPU from Intel Oak Springs Canyon. You also see a Tofino-based intelligent switch. All of these with a P4 front end. But the other thing that's common to this is the SONiC OS, right? You see that up top up there. Another big part of the intelligent fabric is the SONiC OS for the control plane functions. And one of the things that Intel is announcing today is new at the OCP Summit is that we've started, in conjunction with our partner Microsoft, putting contributions into the switch abstraction interface, the SI packet test framework. So that's something we've started today. We expect that to get to about 1,000 tests in the very near future. So we're announcing that for today. Something we're very excited about. One of the next things that we're going to announce today is the table-driven API. Now, I talked about this intelligent Intel fabric having the idea of multiple data plane targets, multiple programmable data plane targets. So starting this week, today, Intel has released into the open source an API to address uniform management of those multiple data plane targets. We call it the Table-Driven API, or TDI. It's a set of control plane APIs for to enable the configuration and management of programmable P4 and non-P4 functions. Pardon me. It's supported across multiple targets. FPGAs, you can see that up here. FPGAs, Tofino, IPUs, other targets as well. And it's going to, based on JSON. Excuse me. Oh, lost my train of thought there. Based on JSON, so it's backend independent, target independent. So what you see here, all objects are represented as tables with match action functionality. Okay, everything loaded at runtime and configurable from a runtime perspective. So this is something that we've open sourced today into p4.org, right? And once again, another way for Intel to help us realize that vision of multiple programmable data planes for the Intel Intelligent Fabric. Finally, at the heart of all of this, right, and something that's kind of near and dear to my heart, right, is the Tofino 3 Intelligent Fabric Processor. We actually announced this, I guess it was last week at Intel On. Nick McEwen up on, I guess it was not on stage, but on video, talked about this product. It's our next generation intelligent switch, Okay. Now, it brings together all three of those vectors we talked about before: intelligence, performance, visibility, and control. Intelligence through its enhanced and its substantial P4 programming capabilities. Performance up to 25.6 terabits per second of throughput for a switch, right? And visibility and control, right? Deep integration of INT across that platform. Now you're going to hear a lot more about the Tofino 3 IFP in the near future, right? But the one thing I wanted to close with is that, you know, that as we said, it's not about bandwidth anymore. We really need to switch to intelligence for the networks of the future. How can you get involved? How can you help? Right? Very, very easily. Contribute to OCP SONiC project. Contribute to the p4.org. Right? Contribute to IPDK.org. We talked about that earlier. It's a brand new, the brand new organization in support of IPUs. Right? Learn about P4 programming. You can come to the Intel Connectivity Academy. You can also contribute to the Intel Connectivity Research Program, which is a focus on resource for P4 programmable pipelines. And with that, I'm going to say thank you and see if there are any questions coming from the audience. It's got to be at least one question. All right. Well, with that being said, thank you all very much. And this was a great first outing, right, for myself. So thank you very much.